In today's video, we will discuss the factoring of polynomials. My name is Mr. Brown and I am a math teacher at the Perry Career Academy. I am joined by Ms. Johnson.
Hi, my name is Connie Johnson and I am the ESOL teacher here at Perry Career Academy. ESOL is English to Speakers of Other Languages.
The intention of this video is to teach background coursework, end of course support to improve the success of each student on their end of course assessments. Students, the Algebra 1 end of course domain structures and content weights are given as follows: equations 30%, expressions 20%, functions 35%, algebra connections to statistics and probability 15%. The problems on this video were chosen based on these percentages. During the end of course test, students are allowed end of course resources which include a scientific calculator, handheld or online, and a formula sheet. The formula sheet includes formulas which are commonly used in an algebra content course.
Students who are enrolled in the ESOL, English to Speakers of Other Languages program are allowed documented testing accommodations, which include small group, explaining or paraphrasing the directions for clarity in English only, repetition of directions in English only, word-to-word dictionaries, English to native language, and extended time.
The content standard of this video is to choose and produce an equivalent form of an expression to reveal and explain properties of the quantity represented by the expression.
Factoring. Factoring a polynomial means expressing it as a product of other polynomials.
Our first factoring method is factoring polynomials with a common monomial factor using the greatest common factor, or GCF. Always look for a greatest common factor before using any other factoring method. Here are the steps. Step 1. Find the greatest common factor. Step 2. Divide the polynomial by the greatest common factor. The quotient is the other factor. Step 3. Express the polynomial as the product of the quotient and greatest common factor. For our first example, we have 6 times c to the third power times d minus 12 times c to the second power times d to the second power plus 3 times c times d. Our first step will be to find the greatest common factor. If we consider positive 6, negative 12, and positive 3, please notice that 3 divides evenly to each one of those. If we consider c to the third power, c to the second power, and c to the first power, please notice that c divides evenly to each one of those. And if we consider d to the first power, d to the second power, and d to the first power, please notice that d divides evenly to each one of those. If we put those together, we get the quantity 3 times c times d. Okay, our next step will be to divide. So we will be dividing 6 times c to the third power times d minus 12 times c to the second power times d to the second power plus 3 times c times d. This whole expression divided by 3 times c times d. We're going to go ahead and divide each one of those individually. So we have 6 times c to the third power times d divided by 3 times c times d. 6 divided by 3 is 2. c to the third power divided by c to the first power. You subtract your exponents to get c to the second power. And then d to the first power divided by d to the first power is simply 1. That leaves you with 2 times c to the second power. If we go on to our next one, we have negative 12 c to the second power d to the second power divided by 3 times c times d. Negative 12 divided by 3 is negative 4. C to the second divided by c to the first is c. D to the second divided by d to the first is d. And that gives you negative 4 times c times d. All right, let's go to the third one. We have 3 times c times d divided by 3 times c times d. That equals 1. And if we put everything together, that will give you 2c to the second power minus 4 times c times d plus 1. Please recall that our third step is to express the polynomial as the product of the quotient and the greatest common factor. Therefore, 6 times c to the third power times d minus 12 times c to the second power times d to the second power plus 3 times c times d is equal to our greatest common factor, 3 times c times d, times our quotient, which is 2c to the second power minus 4 times c times d plus 1. Here are some factoring examples that you can try on your own. You may want to pause the video at this point so that you can work out these problems. At this point, you can go ahead and check your work on these 3 practice problems. And in our next video, we will discuss another factoring method.